When calculating the cubic inch capacity of electrical boxes, a common question arises regarding the discrepancies between manual calculations and the values presented in National Electrical Code NEC Table 314.16a. This table provides standard fill capacities for various metal boxes, and understanding the basis for these values is crucial for ensuring code compliance and safe electrical installations. The key difference lies in what each calculation method considers. When you manually calculate the volume of a box by multiplying its dimensions, such as length times width times height, you are typically calculating the overall external volume. This includes the space occupied by the box's walls themselves. However, Table 314.16 lists the internal cubic inch capacity of the box. This internal volume represents the usable space within the box for conductors, devices, and fittings. The difference arises from the thickness of the box's material, usually metal. This material occupies a portion of the overall volume, effectively reducing the space available for wiring inside the box. Let's consider a specific example. Suppose you have a square box with external dimensions of 4 inches by 4 inches by 1.5 inches. Your calculation might yield a volume of 24 cubic inches. However, upon consulting Table 314.16a, you find the listed capacity for this box to be only 21 cubic inches. This difference of 3 cubic inches is attributable to the thickness of the box's metal walls. To further illustrate, imagine that the metal walls of the box are 0.25 inches thick. This means that the internal dimensions of the box are smaller than the external dimensions by twice the wall thickness on each side. Accounting for this, the internal dimensions would be approximately 3.5 inches by 3.5 inches by 1.25 inches, resulting in a smaller internal volume that aligns with the values in Table 314.16a. The code mandates using the internal volume specified in Table 314.16f for box fill calculations to ensure there is adequate space for safe conductor termination and heat dissipation. Overfilling boxes can lead to overheating, insulation damage, and potentially hazardous conditions. Therefore, always rely on the listed capacity in the table rather than simply calculating the external volume. To accurately determine the required box size, it is essential to understand how to apply the fill calculations outlined in the NEC. This involves accounting for all conductors entering the box, including hots, neutrals, grounds, and equipment grounding conductors. Each conductor size is assigned a specific cubic inch value, as detailed in the code. Additionally, allowances must be made for devices such as switches, receptacles, and internal cable clamps for support fittings. Each device counts as 2 conductors based on the largest conductor size connected to it. Internal cable clamps also contribute to the box fill calculation. Once you have determined the total cubic inch requirement based on these factors, you can then select a box from Table 314.16 that meets or exceeds this capacity. Remember that it is always permissible to use a larger box than required, but never a smaller one. The importance of adhering to proper box fill calculations cannot be overstated. Overcrowding electrical boxes not only violates code requirements, but also creates significant safety risks. Insufficient space can cause conductors to overheat, leading to insulation breakdown and potential short circuits or fires. Furthermore, cramped conditions make it difficult to properly terminate conductors, increasing the risk of loose connections and arcing. By understanding the difference between external volume and internal capacity, and by diligently applying the fill calculation rules, you can ensure safe and compliant electrical installations. Always consult the latest edition of the NEC for the most up-to-date requirements and guidelines. Let's delve deeper into the specifics of box fill calculations as outlined in the National Electrical Code. The NEC provides a detailed methodology for determining the minimum size of electrical boxes based on the number and size of conductors, devices, and fittings contained within the box. The fundamental principle is to ensure that there is sufficient free space inside the box to accommodate all these components without overcrowding, which could lead to overheating, insulation damage, or difficulty in making secure connections. The first step in performing a box fill calculation is to determine the number of conductors that must be included in the calculation. This includes all insulated conductors, both solid and stranded, that enter the box and are not terminated or spliced within the box. Each conductor is counted individually, and the size of the conductor, as measured in American wire gauge (AUG), determines its corresponding volume allowance. For example, a 14 AWG conductor requires a smaller volume allowance than a 12 AWG conductor, and so on. Table 314.16b within the NEC specifies the cubic inch volume allowance for each conductor size. Once you have determined the number of conductors and their respective sizes, you can calculate the total volume occupied by the conductors. This is done by multiplying the number of conductors of each size by their corresponding volume allowance from Table 314.16b and then summing up the results. In addition to conductors, allowances must also be made for any devices that are installed within the box, such as switches, receptacles, and dimmer controls. According to the NEC, each device counts as 2 conductors based on the largest conductor size connected to the device. For example, if a switch is wired with 12 AWG conductors, then the switch counts as 2 12 AWG conductors for box fill calculation purposes. This allowance for devices accounts for the space occupied by the device itself, as well as the additional space needed for making connections to the device terminals. Furthermore, allowances must be made for any equipment grounding conductors that enter the box. The NEC allows for all equipment grounding conductors to be counted as a single conductor based on the largest equipment grounding conductor entering the box. This simplified approach streamlines the calculation process while still ensuring adequate space for the grounding conductors. However, if any ungrounded conductors such as hots or neutrals are present in the box, an additional conductor allowance must be made. In addition to conductors, devices, and equipment grounding conductors, allowances must also be made for any internal cable clamps, support fittings, or fixture studs that are located within the box. The NEC specifies that 1 or more internal cable clamps count as a single conductor based on the largest conductor entering the box. Similarly, support fittings and fixture studs also require an additional conductor allowance. Once you have accounted for all conductors, devices, equipment grounding conductors, and internal fittings, you can determine the total cubic inch volume required for the box. This is done by summing up all the individual volume allowances for each component. The resulting total represents the minimum internal volume that the box must have in order to comply with the NEC requirements. After calculating the total cubic inch volume required, you can then select an appropriate box size from Table 314.16 in the NEC. This table lists the standard box sizes along with their corresponding internal cubic inch volumes. When selecting a box, it is important to choose one that has an internal volume that meets or exceeds the calculated volume requirement. It is always permissible to use a larger box than required, but never a smaller one. Using an undersized box can result in overcrowding, which can lead to overheating, insulation damage, and difficulty in making secure connections. In addition to the general box fill calculations outlined above, the NEC also contains specific rules for calculating the fill of conduit bodies, such as LB fittings, T fittings, and pull boxes. Conduit bodies are often used in electrical installations to provide access to conductors for pulling, splicing, or making connections. The fill requirements for conduit bodies are similar to those for standard boxes, but there are some important differences to keep in mind. Firstly, the NEC specifies that the volume of a conduit body must be calculated based on its physical dimensions rather than relying on a table of standard fill capacities. The volume is calculated by multiplying the length, width, and height of the conduit body, taking into account any internal obstructions or fittings. Secondly, the NEC provides specific rules for determining the number of conductors that are permitted to be installed in a conduit body. These rules vary depending on the size and type of conduit body, as well as the size and number of conductors. In general, the fill requirements for conduit bodies are more restrictive than those for standard boxes, due to the smaller physical size and limited access. It is important to carefully review the NEC requirements before installing conductors in a conduit body to ensure that the installation complies with the code. Failure to comply with the box fill requirements in the NEC can result in serious consequences, including code violations, safety hazards, and potential liability. Electrical inspectors are responsible for verifying that all electrical installations comply with the NEC, and they have the authority to reject any installations that do not meet the code requirements. Code violations can result in fines, penalties, and the need to redo the installation at additional expense. More importantly, non-compliant electrical installations can pose significant safety hazards to building occupants. Overcrowded electrical boxes can lead to overheating, insulation damage, and potential short circuits or fires. These hazards can result in property damage, personal injury, or even loss of life. Therefore, it is essential to take the box fill requirements seriously and to ensure that all electrical installations comply with the NEC. By understanding the principles of box fill calculation and following the guidelines in the NEC, you can help to ensure the safety and reliability of electrical systems. Always consult the latest edition of the NEC for the most up-to-date requirements and guidelines. If you are unsure about any aspect of box fill calculation or electrical installation, it is always best to consult with a qualified electrician or electrical engineer. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to perform the work safely and correctly. Always prioritize safety and compliance when working with electricity. Remember, accurate box fill calculations are essential for ensuring safe and compliant electrical installations. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrician when necessary. This will help to avoid potentially dangerous situations and ensure the long-term reliability of the electrical system.